Hi guys, I'm Pedro and I'm back in Headstarter. These past 2 weekends I built FirstModel, an agent that takes a data file and builds your first machine learning model. The first question is why? And the thing is, non-technical users have no idea about how to pre-process, analyze, pick, and train models. And on the other side, I heard a lot from data scientists that say preprocessing is very hard and the most tedious part of their job. For both, prototyping is very slow and a lot of time is lost before they begin actually model tuning. The solution for this is FirstModel, and again, it's going to be an end-to-end agent that generates and deploys your first model in just a couple minutes. All the profiling, preprocessing, and training is done for you, but you have access to the pipeline the agent uses, along with the preprocessing, hyperparameters. You can download this if you want, or you can try it out in the automatically deployed endpoint. The general architecture is very simple. I use Next.js for the front end, Convex for the backend and database, Fast API for the orchestrators, and whenever I need to, I spin up model for the isolated containers. Again, since the agents are going to be generating and running code, all this is run inside a model. The front end architecture is very simple. I have multiple convex queries and I also have multiple convex mutations. The way the user flow works is the user uploads a CSV that gets sent to convex. That's going to show into the dashboard. From the dashboard, you can pick a database. Then you can tell the agent to begin preprocessing. That's going to be a convex mutation. And within that mutation, there's going to be a call to the fast API endpoint, which is going to spin model instances whenever it needs to. The backend architecture is very simple. Orchestrators are nothing more than agents on a feedback loop. And the way they work is they check if there was a previous run, or if there was a failed run, or if nothing run before. If that's the case, then they run, they spin a model instance. That instance is going to read the CSV, it's going to extract information from it. Then we send this information to GPT-5 with a prompt to tell it to tell us code to perform preprocessing on this data. Then we take this code, we spin a new instancing model to run this code, and within this instance, we upload the preprocessed CSV back into Convex, and we set a flag as the run has completed. Then we feed this information again to GPT-5, which can preprocess again this information, or which can preprocess this information in case it failed the last time. The ML orchestrator is very similar. The main difference is that it takes all the information from the preprocessing. So it takes the profiling, takes the preprocessed CSV, it takes the data attributes, and it has a different prompt. So here, instead of telling it preprocess the data, we tell it create a plan to train and predict or classify this column in this data. Then we send this to GPT-5. It's going to generate some run configurations. Pretty much it's going to choose top 3 models that it thinks they're going to be more efficient according to metrics that it's going to pick. And then that's going to generate code and hyperparameters to train. After that's done, we can run the training ourselves. Basically, we send these training data and hyperparameters to model instances, and after that's done, we upload the whole pipeline back into Convex, and we also store the metrics. The last endpoint is the model tester, and that's very simple. That's use an endpoint where we set a pipeline ID along with input data. Basically, it's going to run predict on that input data based on the container. Now let me show you the demo. Okay, so the website is deployed on firstmodel.pnad.dev. The website looks like this. You can try it out. That's going to send you to Studio where you can choose a file. You can upload it. That gets uploaded to Convex. Then you can go to datasets. You can pick the database or CSV that you uploaded. You can hit preprocess. From here, you can override some info if you want to, like you can choose a target column, task type, ID, or if you want to do something specific with the missing values. Otherwise, you can use click preprocess. That's going to start the agent. And after that's done, you can run profiling to get some info on this preprocessing. Basically, preprocess again, calls the agent, send the CSV, get some data from that CSV. Also, it's going to infer some data types, and it's also going to call describe on the CSV. That way, the agent is going to have info about all the statistics about each column. And with this data, it's going to generate this profile summary, which is what it thinks about the data on the CSV. You can also preview data if you want to. Once you're done with that, you can go to train and you can click generate run config. So that's going to store the ML orchestrator. That's going to take a little bit. Something takes a couple minutes. And again, it takes a while because it's running a feedback loop and it's taking everything we had done so far and it's sending it to the agent. Basically, when we click that, it's going to spin a new model container. It's going to load the preprocessed CSV. It's going to load the profile summary, and it's going to give the prompt of generate a training plan for this data to predict the target value. Once that's done, it's going to recommend their hyperparameters, and it's going to run again to try to improve it. Once that's done, the training config is going to show up over there. But again, it takes a couple minutes because it's running. It may take multiple times until it feels it's ready, although I had capped it for performance reasons. Here you can see the latest training config. Basically, it's recommending us to use these models. It's recommending us these preprocessing steps. It's going to drop these columns. These are the numeric features. And after all this is, if it looks fine, we can train the models. This is actually fairly fast because we use run the models with the hyperparameters that the agent already chose for us. And also the other nice things about using model is that we can run training in parallel. So training is done very fast compared to the agent itself. Once the training is completed, we can go to results. And in this page, we can see the results from models. I show the metrics for balance accuracy, precision, recall, and F1 score. And I also recommend the best model by averaging its metrics. From here on, you can choose to download the model if you want to, or you can also test it if you want to from the deploy endpoint. If you click test model, it's going to send you to this page where you can load from the samples. You can choose any row. You can modify the inputs if you want to. If not, you can just click predict, and that's going to call predict on the pipeline that we just built with this input data. Again, it's pretty much just taking all these feature inputs and it's sending it to the appropriate predict pipeline. In this case, we got a predicts class 0 with 93% accuracy. And that's pretty much it. Again, you can test it out in firstmodel.pnav.dev.